Good afternoon, students. Now, in this class, we are discussing about the bridges which are used to measure the low resistance and medium resistance values. Okay, so in previous class, we are discussing about the all AC bridges. Okay, so the bridge measurement of inductance and capacitance. Okay, so as well as you have to see the some of the methods to find out the high resistance, low resistance, and medium resistance. We have to remaining topics are Kelvin's double and Wheaton bridge. Okay, so the Kelvin's double bridge is used to find out the low resistance value. Low resistance is nothing but the resistance value which is less than 1 kilo ohm. That resistance will be called as low resistance. Okay, so to find out the low resistance, we have to use Kelvin's double bridge. To find out the medium resistance, that means in between 1 to 100 ohms. Okay, so 1 ohm to 100 ohm. Okay, so the resistance value will be lies between 1 ohm to 100 ohms. That resistance will be called as the medium resistance. Okay, to have to find out the medium resistance value, we are to use the Wheaton's double bridge. So now in this class, we are discussing about the first of all Wheaton's bridge. See, Wheaton's bridge. Okay, so this bridge is used to find out the medium resistance. That is the resistance value which is lies in between 1 ohm to 100 ohms. Okay, so it works on the principle of null deflection. Okay, so it will be works on the principle of null deflection. Okay, so whenever the galvanometer will shows the null deflection, see here the bridge consisting of a, as usual all bridges, this bridge is also consisting of a 4 arms AB, BC, CD, AD. Okay, so these 4 arms having 4 resistance value. Okay, in 4 arms the current flowing through the AB you can assume I1 and BC you can assume I3 and AD you can assume I2 and in CD you can assume I4. Okay, so and you have to giving the battery, okay, supply in between the points A and C and in between the points B and D you have to connect the galvanometer. Okay, so it works on the principle of null deflection. The bridge is said to be balanced when there is no current through the galvanometer. Okay, so whenever there will be no current, that means zero current will flow through the galvanometer. So at that time the bridge will be in balance. Okay. Okay, this condition occurs when the potential difference across A to B and A to D are equal and the potential difference across the B to C and C to D and remains same. So that means whenever whenever the bridge will be balanced, it means whenever the potential difference across EAB is same as the EAD and EBC is same as the ECD. Okay, so that means at the time the potential difference across B. So here you can assume the resistance will be P. So at that time the voltage value means is nothing but the product of the current and resistance. So at that time you can write I1 into P. So and you have to write the voltage drop across AD is nothing but okay I2 into R. So at that time, so you have to write I1 into P and equal to I2 into R. Okay, so the bridge in a balanced condition is expressed as, so at that time I1. So I1 is nothing but, so I1 is equal to I3. Okay, so the current which is flowing through arm AB is same current will flow through the arm BC. So at that time you can write I1 is equal to I3. So that is equal to E by P plus Q. Okay, so that means voltage by resistance, sum of resistance. Okay, so that means the current I1 will flow through P and I3 will be flows to according to current divider rule. Here you can write I1 is equal to I3 equal to E by P plus Q. Similarly, I2 equal to I4. Okay, that is equal to E by R plus S. By substituting the value of I1 and I2 in the equation 1. So now here in the place of I1, here you can substitute E by P plus Q and in the place of I2, here you can substitute E by R plus S. So at that time you can get See. So you have to substitute in the place of I1 E by P plus Q, in the place of I2 E by R plus S. So at that time here you have, so E will be get cancelled. So at that time you have P by P plus Q is equal to R by R plus S. So at that time here you have to cross multiply. So whenever this term will goes to this side and this term will goes to this side. So at that time here you can write P into R plus S. So whenever this term goes to this side, at that time here you can write R into P plus Q. So at that time this will becomes PR plus PS and this will becomes RP plus RQ. So here which terms are same? PR will be same. So at that time these two terms will be cancelled. So at that time this equation will be is equal to PS equal to RQ. So here see in bridge. So in first here in bridge. So this is standard resistance. This is R. This is R will be nothing but unknown resistance. The resistance which is to be find out. Here you have to connect the in between the arm A and D. Okay, that resistance will be assumed as R. Okay, so these two are known resistance value and this one is a known variable resistance value. So here R is unknown resistance, that is medium resistance which is to be find out by using the Wheaton's bridge. So at that time, so the equation will becomes here you have R value. So at the time you can put Q in this side. So at the time you can here you can write P by Q into S. Okay, see that means the value of unknown resistance R is determined by the help of equation number 3. Okay, so by using this equation, by using the Wheaton bridge, you can find out the unknown resistance value. Okay, so the R is the unknown resistance and S is the standard resistance of the bridge and P and Q are the ratio arm of the bridge. Okay, so this is about the Wheaton's bridge. Kelvin's double bridge. Okay. So Kelvin's double bridge is used to find out which value? Low resistance value. Low resistance means the resistance which is less than 1 ohm. Okay, so that resistance will be named as low resistance. So here Kelvin's double bridge, it is also consisting of 2 ratio arms. Okay, so see, this having extra 2 arms. The ratio arms, those are nothing but small p and small q. That's why this is called Kelvin's double bridge. Okay. So the P and Q is the first ratio of the arm. P, a capital P and Q are called the first ratio of the arm. Small p and small q is the second ratio arm. Okay. So here see, here also you have to connect the P in between points A and B. So similarly in between points A and C you have to given the supply value and here R is unknown resistance which is to be find out and R is the standard resistance value. Okay, so under balanced condition. So under balanced condition, zero current will flow to the galvanometer. Okay, so the potential difference between point A and B is equal to the voltage drop between the points E, A, and B. So see here. EAB is equal to EAMD. Okay, EAMD. So that means now you have to write EAB and EAMD values. So at the time here you have to write. So see now EAB equal to have to write according to voltage rule EAB equal to P by P plus Q of EAC. Okay, see, so at that time EAC, you have to write EAC value. EAC means the voltage drop across A points between A and C. Okay, so voltage drop is nothing but, so this is according to the voltage divider rule, you have to write EAB equal to P by P plus Q into EAC. So EAC is equal to 1 plus I into R plus S plus P by P plus Q. See, how you can get this one is EAC is equal to I into R plus S plus P plus Q plus R by divided by P plus Q plus R. So EAMD is equal to EAMD. So EAMD is nothing but, so at that time here you have C. So EAMD. So here you have two parallel combination of P plus Q and R value. Okay, so in between EAMD. So at that time here you have to write, okay. So at that time EAMD is equal to I into R plus P by P plus Q into, okay, P plus Q into R divided by P plus Q plus R. Okay, so R means internal resistance. Okay, so at that time EAC will becomes, okay, so EAC is equal to I into PR by P plus Q plus R. So for 0 galvanometer deflection, here you can write EAC equal to EAMD. So EAC means P by P, I into PR by P plus Q plus R. EAC value will be IP plus, EAMD value is P by P plus Q into I into R plus P by P plus Q into P plus Q into R divided by P plus Q plus R. So from this, by solving this equation, here you can get R value. So at that time here PP, directly PP will be cancelled. Okay, so by solving this equation, okay, so once all of you practice this in rough notebook, so by solving this equation, so at that time here you can get R equal to P by Q into S, PR by P plus Q plus R, P by Q minus small p by small q. So here at that time you can write, so you know P by Q is equal to small p by Q. Okay, so first ratio arm ratio is equal to the small ratio arm. So at that time you can substitute here in the place of P by Q. So at that time small p by Q minus small p by Q will becomes 0. Okay, so that term at that time this total term is equal to 0. At that time the formula to find out the unknown resistance by using the Kelvin's double bridge is capital R equal to capital P by capital Q into capital S. Okay, that means these are the first ratio of P and Q are known resistance value. S is the standard resistance and R is the unknown resistance value, the resistance which is to be find out. Okay, so potentiometer method. Okay, so the potentiometer method is also used to find out the measurement of the low resistance value. Okay, see here, this is the arrangement of the potentiometer method. Okay, so here you have to giving the stabilized DC supply, okay, through to the rheostat. Okay, and here you have to one standard resistance, and here you have one unknown resistance. Through this unknown resistance, you have to connect the one ammeter. Okay, so and here we have the tappings. Okay, so consider that when a switch is in position 1-1, the voltage drop unknown resistance is VR. See here, whenever the switch is at 1 and 1 so at that time you have to close this one. At that time the voltage drop is nothing but across the unknown resistance is VR. Okay, here unknown resistance will be assumed as the VR. So that VR value will be given by VR is equal to IR. Okay, so VR is equal to IR. Okay, and when it is 2-2 whenever the voltage drop across the resistance, that is standard resistance value. Okay, so at that time the standard resistance will comes into the circuit. So at that time here you can write Vs is equal to Is. Okay, so whenever you have to write VR by Vs, so you have to write VR by Vs, VR value will be IR and Vs value will be Is. So at that time II will be cancelled. So at that time VR by Vs is equal to R by S. So that means R is equal to VR by Vs into S. Okay, here R is nothing but the unknown resistance value. Okay, that is the resistance which is to be find out. Okay, so yeah, S is nothing but standard resistance. Okay, so here VR, you know, VR value, Vs value and S value. So at that time you have to find out the unknown medium resistance value. Okay, so this is the one of the method, that means low resistance. So potentiometer method is also used to find out the low resistance value. Okay, so these all are discussed in earlier ammeter voltmeter method. Okay, substitution method, these all are used to find out the a medium resistance value. Okay, so now in this class we have to discussing the Kelvin's double bridge, resistance bridge, and one of the method to find out the low resistance value, that is nothing but the potentiometer method. So the Kelvin's double bridge is also used to find out the low resistance value. Resistance bridge is used to find out the medium resistance value. Okay, so in previous class I have to discuss the ammeter voltmeter method, Kelvin's double bridge method. Okay, so now in this class we have to discuss the Kelvin's double bridge method and potentiometer method. Okay, these are the methods is used to find out the measurement of the low resistance. Okay.